Kia ora tātou. Welcome to Arch and Z. I'm Kirsty Mackie and it's my pleasure to welcome you to the third Arch and Z webinar. We have a very exciting webinar lined up for you today, all about that day 2 years ago when Auckland stopped moving. No, I don't mean because of COVID, I mean literally because of the Harbour Bridge closure. Today we're going to look at how laser scanning helps speed up the process of fixing the bridge. So just a little bit of an overview of the agenda for today. First, I'm going to overview Arch NZ and what it's all about, reminding everyone what our purpose is and what we're trying to establish with this group. And then second, we will hear from Nathan Cossar from Envivo. He's a laser scanning manager there, and he's going to talk about how they use the RTC 360 for fixing the Auckland Harbour Bridge. Then we'll go on to Q&A. If you have any questions whilst we're going, please put them in the questions tab down below and we'll answer them at the end. And lastly, we will outline some of the upcoming webinars. We've got a few already lined up, which are very exciting, so keen to give you an overview of some of those. But first, just an introduction to me. I'm the new Autonomous Survey BDM at Global Survey. I will be focusing specifically on reality capture, sales and support for the North Island. I've been in New Zealand for the last 7 years, but I'm originally from the UK, as you can probably tell. My background is a little bit different. I have a BSc in geography where I looked at laser scanning, remote sensing, used dumpy levels to look at glacial landforms. On the screen, you can see some photogrammetric point clouds from Fox Glacier in the South Island from that. Since then, I've worked at Asbuilt, focusing on scan spin workflows and visualization processes. And then I've also worked at Becca, looking at scanning from within a survey section and beyond to the wider applications across the business. I'm currently based in Auckland, but will be around the country for this role quite a lot, so probably see you in your places. I'm particularly passionate about 3D data, especially how it links into different online environments, especially how it goes into visualization, CAD, GIS, and BIM, just the whole integration and digital strategy behind where the outputs go. So what is Arch NZ? Arch NZ is a community group for reality capture professionals, focusing on the future of automation in the capture, processing, and delivery side of things. It's going to be a platform for sharing innovations and success stories to elevate the knowledge and applications of individual members. Key to it all is that it's a network for all of the reality capture professionals in New Zealand to create a community where we can all network together. We have a LinkedIn group where you can stay up to date on all of the latest ongoings of the group, and we also have an online website through our Global Survey website for catching up on past webinars, so they're all recorded there. So without further ado, let's pass over to Nathan.
Kirsty. So yeah, as Kirsty said, my name is Nathan Cossar. I am the scanning manager at Envivo. So just a little bit about myself. Been working for the company for just on 15 years now. Started off working part-time as an assistant while I was studying, and then moved into becoming a technician. Went overseas for a bit, left on good terms, came back and started working for the company again, and that was in 2013. And then pretty much got into laser scanning straight away. So we started off using the Leica C10, which was at its time was a pretty impressive scanner in terms of technology. But I mean, obviously technology's taken over in those sort of 8 to 9 years now, so things are a lot faster and better quality. So after the C10, we then bought a Faro. At the time, Leica didn't have sort of an option that we were looking for that suited our sort of workflows and the type of work we were doing. So we went with the Faro X330, and that was target-based registration using targets and spheres. And then the software started to adopt more cloud-to-cloud techniques, and then we started taking on those learnings and those approaches, and then moving more onto a cloud-to-cloud based registration for a lot of our work. So fast forward until now, we've now got 2 Leica RTC 360s, so that services pretty much 95% of our work that we do, and they're both really busy every day. They're out there and throughout the country. So we've got offices in Auckland, Wellington and Christchurch, so they get shipped around the country wherever the work is and then deployed to the local team wherever they are. So the Harbour Bridge is probably all of you in New Zealand are very familiar with the bridge. It was built in 1959, one of the iconic structures of Auckland, if not New Zealand, and it helps connect the north to the central/south of the city. So it's a very critical part of the infrastructure and the road network in the city. And if you can't use it, it causes mayhem and traffic, as probably a lot of you have experienced. So just go through the next slide. Cool. So the incident itself, on the 18th of September 2020, 11 AM, it was a pretty terrible day for weather. Don't know if a lot of you can remember that we're in Auckland, but it was pretty horrific. Not a lot of our field teams had to bail for the day, so worried about gear getting blown over and damaged, etc. So what happened within a couple of minutes, 2 trucks were toppled over or on its side. One of them hit the superstructure of the bridge, causing the damage, and then the other one, you can see on the bottom right-hand corner, that lay on one of the barriers in the middle. So that pretty much stopped traffic on a normal, typical weekday that's normally busy anyway. So yeah, that's pretty much it in terms of that. So it's pretty much gridlock all through there and had a massive impact throughout the rest of the motorway system around the city. I found this video online. So this is actually the truck hitting it. So hopefully it comes through clear through the stream of the webinar. But yeah, that was the time. So some guys were just recording the other truck that had toppled over, and then that one was the one that actually hit the bridge and did the damage. So this one just righted itself, as you can see, and then it just carried on off the bridge. So timeline, I've broken down basically a breakdown of what happened from the start to when we delivered. So 11 AM the incident happened. 2 PM we started having discussions with the NZTA regarding a solution and looking to measure the damage and basically see if there was anything else. There was an issue with the bridge that wasn't visible to the human eye. So were multiple emails, phone calls, etc. throughout the evening on Friday night. And we're just talking health and safety, access, all that kind of stuff as you do for most work. 7 AM we're on site, health and safety briefing, escorted up onto the bridge, and then basically on to do our work. So we were given, there's about a 3-hour window to undertake the work. That's because they had a whole lot of other contractors that were coming to inspect and check things. So it was basically whatever we could do in that time. So after I got home, imported the data, and then by 10 PM that night, Saturday night, we had the final point cloud exported, and then uploaded that to our cloud delivery system. And 6 AM woke up Sunday morning and fired that off to the team, and that's when we passed on the information. So pretty much we did that from the actual incident to when we delivered was, I think it was 42, 43 hours. So yeah, it's pretty impressive with today's technology, or us being able to deploy a team pretty fast as well, but that you can capture and register and deliver within that time, because modern technology with scanning and registration and stuff has got a lot more faster, computer power's got faster, so you can import and export faster as well. So the damage itself, so there's some images there. One on the left-hand side, let's get my laser pointer. One on the left-hand side we're taken on site. So there's our scanner set up there. So you can see the big dent that it's created when the truck impacted the strut. These 2 other images here were taken from the media, so it gives you a really good perspective of what the impact actually did to it. And on the right-hand side, you've where the strut comes in. I'm not a structural engineer, but where it basically meets the rest of the structure, the bolts have sheared off there just from the impact. So yeah, it's pretty crazy the amount of damage it did. It's hard to tell how fast the truck was going, but you know, just with that force, what damage is caused. So on-site challenges, so every job that we do poses its own challenges. There's no job that's ever straightforward. There's sometimes ones that go pretty well, and then other ones there's all sorts of tricky things that you've got to deal with, and it comes down to experience and knowledge of the gear and previous jobs that you've done, and all of that gets combined to basically help you through the situation and get the right results for the client. So this image here shows basically a section through the bridge. So under here, we had to access this. There's a walkway that you go through, and then this access underneath the clip-on. So basically, for those of you who don't know, the original bridge is actually this part here. So that was the one that was built in the 50s. And then, not sure on the date, but basically a Japanese company was involved in engineering and adding on these clip-on lanes. Because the city was growing and traffic flows required a larger bridge. So these clip-on lanes move up and down as there is depending on the amount of traffic on it. So this bridge is fairly stable. I mean, obviously it moves around in the wind and stuff. Structures are designed to do that, but the clip-ons, you can actually see them visually moving. And when we're walking underneath here, the bridge guys were letting us know it was coming down, and it just slowly moves down. So up to half a meter it can move vertically, which is it's pretty crazy to see. When you drive over the bridge, you don't see it because you're driving 80 k's. It's something you don't normally notice. So just a bit more zoomed in on that photo here. So I'll just run through a couple of aspects of this job. So we've got the road deck of the bridge. So we were running our scanner with cloud to cloud, so we weren't using any targets. For this, we traditionally run survey control in all of our work, because of the nature of the site and things moving around, and we weren't required for any coordinate systems or anything like that, height datums and all that. So we ran the scanner as it was, and we did the appropriate checks afterwards to make sure everything was tight. So setting up on the road deck, so that's the main road there, so traffic's normally flowing through here. So in terms of cloud to cloud, we've got really good overlap and balance of all the superstructure above. But that being said, it's not an environment that is great, such as working in a plant room or inside a building where you've got solid walls and ceiling and structural members above, which is really, really great for cloud to cloud. So it's not the ideal environment, but through a number of techniques and our learnings, we basically mitigate those issues, and we still get the good results that we try and achieve. So the clip on here, that, as I said before, that's moving up and down. So that creates issues in the registration, which we've got ways of resolving that. We've also got the moving traffic as well. The narrow access way was pretty tight through there. It took about 15 minutes to walk around, so we kind of lost 15 minutes of our available time on site just to get in there. And just zoomed in a bit further. Couple of other things. So these were the main areas that were the really tricky points of this job. So we've got a protected rope in here. This is for people chuck rubbish and whatever outside of their cars when they're driving past. So this protects any people that are working below down in here, as well as basically there's a gap that goes straight down. So any boats, yachts, whatnot that are traveling underneath the bridge, stopping a bottle landing on them. That being said, you can still chuck stuff off the other side of the bridge. There's nothing protecting there, but that's just to protect probably mainly people that are working in here. Then we've got a narrow gap. So that gap is 350 mils. So that's pretty tight. That's probably about the width of our scanner, to be honest. So the issues here is trying to get common data between here and going back up and allowing that for your registration to be complete. So that was probably the trickiest bit. And the clip-on, moving, we measured it was around about 200 to 300 mils, but the bridge guys were saying up to half a meter. So this is looking underneath. So that image before where those people were standing in the high-vis jackets, what we've got. So we've got like a boardwalk here. This kind of a plastic, rigid mesh type material. So in terms of cloud to cloud, it's not great. It's not a great environment for it. In terms of amalgamating the scans together. We've got the narrow gap above before. We've also got a steel cage, so there's some cables that run through here. So the steel cages to connect, to cover, to protect those, sorry. And then bulwark grip textures. So all of this together here for cloud to cloud to work, when you're scanning here. This environment's fine for scans running along this area, but trying to connect to this environment, the environment above, is quite tricky. So we've got some photos here. This is our scanner set up just on basically on that beam running across. The legs are flat, so it's sitting basically at that level. You can see the net here. So we asked for this net to be removed, and the guys tried to do their best to get approval for that, but they couldn't for health and safety reasons. They didn't want to remove it, so that's fine. And then on the left-hand side here, you've got just seeing that gap. So that's looking back up. So where we were on that boardwalk before, if you're standing there looking up, that's your view that you can see up there. The image on the left is looking down. So on the bridge deck level, if you looked over the barrier, that's what you see down. So you've got the net over here. It might be hard for you to see, but where my pointer is, that's the boardwalk texture as you're looking down. So that's kind of when we're scanning, I've got the scanner on its side and we're measuring down there. When we're scanning down, we're trying to capture as much overlap as possible to connect the two areas together. On the right-hand side, this is an image from TrueView, from the LGS file. So you can see up through the netting, you can see what the net is causing a bit of an issue in terms of creating as much overlap as possible. So we still got a lot of data through there, and these scans connecting to the upper ones on the bridge deck, they connected in pretty well. But it was the issue was connecting these ones down to the lower part where that walkway was. So basically, in the end, we registered everything up the top, everything down the bottom, but I couldn't confidently get a really good registration output from the two. So therefore, I made the call to deliver the two separately as different coordinate systems, both relatively very accurately, accordingly correct, sorry, they're accurate. But the relationship between the two, I couldn't get them to the accuracy that we normally require. And anything that's sort of outside of those normal tolerances, I'd rather not deliver, because once you send a file information, you never have control over who's using it and how they're using it. And we don't want information to mislead any measurements or anything that anyone's taking. So I made the call to deliver them separately. But the main area that they're after was actually where the damaged strut was. So a couple of solutions with the problems that we face. So initial site visit would have helped us understand the site a bit better. That being said, based on us not being able to remove the netting and scan the way we could have scanned, it couldn't really resolved anything, but at least we could have started the conversation early. And maybe if we had talked about it on that Friday night, maybe things could have been different and someone could have been there to remove the net. Installing targets and using a target-based registration between the two areas. So that could be another option. Didn't have any targets on me at the time. We didn't actually know that we'd be scanning underneath. There was no brief or anything, or we didn't know what we're actually doing. It was really just turn up at 7 AM, bring your scanner, and let's see what we can get. So that being said, if you go back to what I said before about the initial site visit, we could have brought targets along and that would have helped with the registration, connecting the two areas together. Completely removing the rope. That would have enabled a clean registration. So removing that there, we could have done a lot more scans, transitioning down from the upper to the lower, and basically run like in a way, it's kind of like a vertical doorway scan, transitioning through the area. So that would have worked well. The clip-on bridge moving, the materials down the bottom of the walkway and all that, they're no problems. We've got solutions to that. But it was the rope net that was the main thing. And more time on site. Technically, if we had done 5, 6, 7 more scans, we had time to do that. Maybe could have enough overlap to register it together. But hindsight, just never know. So the information we provided, though, was well received, and it was better than having nothing, I guess. So point cloud images. These are just some images I've taken here, just to show in detail the bridge structure. Go through there. That's looking out. For those of you who are not familiar with working with point clouds, I don't know who the audience is, but that's basically, I guess that view is out above the water, sort of at bridge level, but that's looking back at the point cloud in 3D. So we haven't scanned from that exact position, but that's looking at the 3D model in 3D. That there is looking at the damage to the structure, so that's in an orthographic view. So you should have a nice symmetrical view of the strut on this side is there. But you can see the damage is really, the impact has really pushed that up and also displaced this area as well. And then there's just another view there. So you can see the damage there. You can see the curve from the dent. So we'll talk about the analysis soon that we did in 3DR and just to give a bit more detail about what the impact actually did to the structure. So this is a fly through. This is the final point cloud that we delivered. So it just gives you an idea of how much information we collected. So I think it was about 38 scans we did all up. Probably about 25 were done on this level here. Set the scan resolution to high, so that's for the RTC, that's 3 mils over 10 meters, because we wanted to get as much information as possible, as well as allowing us to create the tightest registration we can as well. If you had a lower resolution scan in this type of environment, your registration is not going to be as tight as it would be with having more data in there, because the software's got fewer points to go off. So yeah, highest resolution there. So you can see on the right hand side of the video here, the data starts to cap off there. That's because the RTC has a maximum range of 65 meters at the highest resolution. So after 65 meters, there's just no return from the laser, and therefore there's no data there. So this is the point cloud here. It looks like a mesh, but it's not. I've just turned the point density up just to kind of fill in the gaps. So normally if you're looking at a normal view like the previous images, you do see more of the dots, but here it looks a lot more full, but it is actually the point cloud. And you can see the amount of detail that's picked up on the mesh, on the netting through here as well. Protective netting you can see there. And these gaps on the right hand side, for those of you that might not be familiar with point clouds, so that's because we couldn't access the clip-on lane here because there was it was live lanes of moving traffic. And you can see all sorts of colors and funny noise and stuff. That's from all the cars driving past, and the scanner capturing points at the same time, and then it runs photography after that and overlays the photography over the points. So that's why you got sort of funny kind of streaky sort of patterns there. Okay, so the 3DR analysis, this was probably the most critical information I think that we delivered from my point of view. You know, in terms of the bridge itself, there is a dedicated team that has drawings and models and stuff of the bridge. So we weren't reinventing the wheel here. There was already information on the bridge, so that was already in place, I'm sure. But this here, so basically, Cyclone 3DR, for those of you who don't know, basically it's a Leica package. You can also do all sorts of extraction, meshing, analysis. So what we did here is created a mesh from this, which is basically a triangulated surface. And then from here, we did a floor, what was it? It was a surface levelness. That was the setting that I used in 3DR. So basically, in effect, it's checking the flatness or the deviations across it, perpendicular to gravity. So if you were picturing this was turned on its side, and that was actually the floor, we're just checking how flat it was. So there's a couple of settings in 3DR which enables you to correct that quite quickly, but it wasn't working very well. I think the software is looking for a lot more information. So I couldn't quite it. I knew exactly what it should look like because I knew full well that this should be pretty flat along here, or you'd hope it would be. And I was getting quite a bit of deviation across there. It was tilted, and I could tell it was tilted. So ended up applying UCS manually through trial and error until I got it to fit. And from there, I also verified in 3D on our point cloud just to check that there was nothing going on and that the information I was providing here was correct. And you can see here from the color banding, so basically anything that's green is deemed flat, and anything that's outside of that green is where the displacement starts. So basically at the big dent here, we can only measure one side of it, but the displacement there was 390 mils. So assuming that the bridge was all square and plumb, which should be pretty close, that's how much displacement there was from the impact. So You can see pretty much here, I don't know how clear it is through the webinar stream. So that's basically about there is where the change in the structure starts there, and then it gets worse and worse as it travels down to where the main impact was. On the right hand side, it's just a more zoomed in version, just to see that impact there. Okay. So final slide here. So this is the final repair. Obviously, we didn't have any input into this in terms of our work. Our work was kind of done post delivering the point cloud and the analysis. But basically, it's pretty impressive that 16 days after the incident, the repair was installed and the bridge was back to normal. So yeah, it's great to see New Zealand industry, I guess, getting in there. I'm pretty sure this company was in Whangarei, if I'm correct. I'm not pretty sure that was in the news article. So yeah, this steel strut was created in that time and then driven down to Auckland and then installed. So I think they obviously did a few tests. They would have had to check everything before the bridge was put back to full capacity. But yeah, once it was in, back to normal. Cool, so that's it for me. Yeah, really appreciate time for everyone listening, and I'll hand it back to Kirsty. There might be a few questions, but yeah, thanks for coming.
Great, thank you for that, Nathan. Can you switch this presenter view? Ah, yeah. Sorry, can you guys see my screen there?
No, not yet. Do I have to turn off mine, do I? Or how do I? There we go. It's working now.
Let me know when you can see the slide.
Yep, it's there.
Okay, perfect. So we have a few questions. All of them are for you so far. So first off was about the density settings. You mentioned that you were using high density scans.
Yep.
Did you do all of the scans on high density, or did you do some of them on medium, and why?
Yep, good question. So all of them on the actual road or the bridge deck was high res, high density, and I'm pretty sure everything else was medium. Medium's pretty much the standard. So for those of you who don't know, it's 6 mils over 10 meters. So if you scanned a wall at 10 meters away, you would have 6 mil grid spacing. Is pretty much what that means. So it all depends. We make that call based on the environment around us and what we're trying to achieve, so what the client wants, how much detail they want, and then we've always got to consider how well, because we're using cloud-to-cloud registration, you need enough points in there to enable that registration to be complete. So it all depends on that, but in terms of the actual question, high res on the bridge, and I'm pretty sure most of it was medium res down below.
Awesome. We had another question about the noise as well that you were mentioning between the two groups when you were trying to join them together. With the section that was moving up and down. Could you also see issues within the individual scans as well, or was it just in when you were combining the two areas together?
Yeah, you do see issues in the scans because every time, so when the scan measures the clip-on, it'll measure it in one position, and then the next scan, when you measure the next 2 or 3 minutes, the clip-on would have moved, so you're measuring in another position. But using the registration software, you can eliminate that and just run it by just using your data that you want to use, basically. So all of the structure that's not moving. As well, just something to add, the bridge does move around as well, but because we're on the bridge and the relative movement of that bridge, the movement of the structure above is not moving different to the scanner moving, if you know what I mean. So it's only the clip-on that's moving independent from our data, so we just remove that from the registration.
Awesome. There was also a follow-up question to that one as well, because obviously you're up on the bridge and it's very windy up there. In the first picture, you've got the carbon light tripod. Did you have any issues with that, or did you try using the heavier one at any stage?
No, we didn't. It wasn't. Sorry, it wasn't actually windy that morning. Well, it wasn't that windy. There's always wind, but it wasn't it wasn't 130k gusts, that's for sure. I don't even think you could do that even with the wooden set legs. So no, it was just standard sort of wind, so didn't have a problem. Did have the tri-brake and the wooden legs in the truck, but yeah, didn't really need it. The storm had calmed by then, that's for sure, because it was sort of 12 hours after the incident.
Yeah, awesome. And I've got another question here about what cloud delivery system you use to give the data over.
Yep. So, the delivery system that we used.
It says cloud delivery system, so I'm just assuming
Okay.
any framework
So that we think we're using Sync at the time, but now we use OneDrive. So that's just to deliver files, basically, in effect, a Dropbox type thing. So yeah, it's nothing fancy, but it was just to show that it wasn't a USB kind of courier kind of thing. It was done over the internet. So but yeah, it's just standard, and the delivery was RCS files, as unified cloud as an RCS format, and then the LGS file, which at the time was open in Jetstream, but now it's TrueView's taken over that. So it's the but same sort of thing.
Yeah, awesome. Well, I think unless anyone else has any last minute questions coming through, that is all of them. Thank you so much for presenting. It was fascinating to see what happened, and amazing that you guys got that going.
Yeah, no worries at all. Thank you.
So we have some exciting talks coming up for the ArchNZ webinars. The next one that we've got planned is on May 10th. It's about automating reality capture with ground robotics. Hayden Bradfield from Joan Deploy, formerly with us at Global Survey, will be doing that talk. And it's going to be a session to walk through how ground robots are being used to automate and provide value to operations all around the world. So sounds very exciting. And then we also have an exciting talk in June from Sam Smith and Steve Hasselmore at Woods, and they're going to be giving us a talk about laser scanning and GIS, all the cool geospatial delivery stuff that they're doing for data processing, management, and visualization, with a specific case study at St. Stephen's School at Bombay. So more details about those will come out soon. As always, if you have any feedback about these webinars, if you want to get in touch and would like to present, or you have any ideas, feel free to contact us via the details below, and don't forget to join our LinkedIn page. And thank you everyone for coming along, and Nathan for presenting again. Hope to see you next time.